Okay.
Cool.
There you are. Perfect.
Yes.
All right. So our topic today is FiberRefs. We did get some requests for a session on Z environment and how we deleted has in ZO 2.0. So we'll definitely do a session. We'll definitely do a session on that one very soon. But this is not that session. This is the FiberRef session. So we're going to talk about what FiberRefs are, some of the ways that they're used in ZO, as well as how we can use them in our own applications. So a FiberRef is the ZO equivalent of a Java thread local. And I think that's how it started off, of just like there was this thing in the non-functional world and we wanted to have an equivalent for it in the functional world. But I think it's ended up really being useful for a lot more than that. And really, whenever you have some kind of, I'll call it scoped information or context, think about a FiberRef. And FiberRefs in the environment, as we'll see, are a particularly nice way to do this.
Naveed asks if you
please.
could briefly go over just thread local. I mean, potentially.
Yeah.
We're
gonna do exactly that, and I think I'm gonna hit it indirectly. I'm gonna talk about a ref versus a FiberRef, and we'll see how that's the same. How that kind of gets us to that same idea of like, what is this thread local thing?
Gotcha.
So let's start with, we have refs and FiberRefs. How are they different? Look at that. I can get autocomplete for that. So if we think about a ref is one value, or maybe we could call it one variable, really. One variable shared between different fibers. And so if we had like a typical ZO program, we might, if we like thought about, maybe we have like 3 fibers. We have like fiber 1 here, and maybe this is going to make the ref with a value of 1. And then we're going to have fiber 2, and later on fiber 2 is going to maybe set it to 2. And then over here it's going to set it to 4. And then we're going to have fiber 3 that's going to, let's say it'll read it here, and then it'll read it again here. And so the defining aspect of a ref, really, and what makes it useful for what we use it for, is that there's, even though there are these different fibers, there's only one ref. So like here, the ref has a value of 1, and then if fiber 2 sets the value to 2, then when fiber 3 reads it, it's going to read 2. And when fiber 2 then sets this value to 4, then when we read it here, we're going to read 4. So the ref is really useful for communicating between these different fibers. So if we could imagine, maybe this isn't like an integer, maybe it's like a Boolean that says like, are we done with our work? And this one is going to set it to being done. And then this one's doing a bunch of work and it's periodically going to check in, is going to check in and is going to read and say, well, oh, I'm supposed to be done now. And then it's going to stop. So the usefulness and the defining feature of this is that there's one value that's shared between all these different fibers, so they can use that value to communicate with each other. So the FiberRef works a little bit differently, and we'll see we can do some fancier things with it, but the simple way to think about it is each fiber gets its own copy of the FiberRef. So and we'll actually maybe add a little bit onto this, and we'll say when we fork a fiber, it gets an initial value equal to its parent's value. So let's look at what the same example might look like if this was a FiberRef. So if this is a FiberRef, then, thank you, as soon as we fork these, each of these fibers is going to get its own copy that's initially going to be the value of its parent, which in this case is going to be this fiber 1. So fiber 2 can set the value to 2 and set the value to 4, but fiber 3 is still just reading its own copy. So fiber 3 here is still just going to read 1 in both of these cases. And so your first question might be, well, okay, well, how is FiberRef useful in this case? Because we can't use it for the same thing we used ref for, right? We can't use it to communicate between these fibers because there's nothing being shared between these fibers of when this fiber does an update, it doesn't affect at all what fiber 3 sees. And that's right, we want to use these for different use cases. So ref is really good for communicating between fibers. And FiberRef is really good for maintaining some scoped state or context. And so to see that, let's like try maybe making this a little bit more concrete versus like these numbers here. So let's say that this ref represents, let's just say it's going to represent some logging context. That's like a example that is a pretty good use case for a FiberRef. And so let's say here we set this as like the Zymposium context. And then we set this as the kit context. And then we are going to log something. And then we're going to set it back to the Zymposium context of we're done with like the section that kit's doing, say. And then let's say here, I'll make this a little bit more complicated. Let's say here we're going to set the Atom context. And then we're going to log something. And then we're going to set this back to the Zymposium context. And this log thing is going to do something with whatever value is set here. So if we use a normal ref, we can see that this is going to kind of create a problem for us because we're going to start with this being Zymposium, then we're going to set it to kit, then we're going to set it to Atom, then the like kit fiber is going to do some logging, but because this Atom fiber like already set the value to Atom, this is going to be Atom instead of kit. So like the advantage of the refs being shared across all these fibers is they can use it to communicate with each other. But the flip side of that is that they can step on each other, which we see here of like, we really want to make sure that when we log here, we log in the kit context, but we've accidentally logged in the Atom context. And we don't really have a good way to control this when we're working with a ref because these two fibers are operating concurrently and we may not even know what other fibers are operating or what they're doing or when they're doing it. So if this was all we had, we couldn't really use this to solve this problem of like making sure that when we logged in the kit context versus the Atom context. But now let's go and let's do the same thing with this FiberRef. So now we start with this FiberRef that has this Zymposium context, and then we create these two new FiberRefs that each have their own separate copies. So now this fiber sets its copy to kit, And since its copy is separate from the fiber 3 copy, the fact that this fiber is doing something with its copy doesn't matter. They're totally different copies. So in this case, this fiber sets its value to kit, then it does its logging in the kit context, and then it sets its value back to Zymposium. And this fiber sets its value to Atom. It does some logging in the Atom context, and then it sets its value back to Zymposium. And so because these values are local to each fiber, we can do logic for this fiber that in a way doesn't have to worry about concurrency in the same way of, since we're the only ones setting our ref, it doesn't matter what other people are doing with their copies. It doesn't matter if there are one other fiber or 100 other fibers. It doesn't matter when or how many times they're setting their values to Adam or John or what have you. For this fiber, it's always going to set its value to kit, and it's always going to log with that kit value. So that's the fundamental idea of a FiberRef. And a thread local is essentially similar of if you have a value that's not a thread local, if you just had a normal like bar or a normal atomic reference, it would be shared among all of your threads. And if you had a thread local, then each thread would get its own copy of that value, and its modifications would only apply to that thread. So the FiberRef just takes that same idea and moves it into the ZO context and replaces the threads with fibers, because the fibers are equivalent of a thread. Does that make sense for folks as a high level idea here? Anything on the Discord?
We got a couple of yeses, a yes and a yup. So I think it makes sense. Yeah, interesting. And so this sort of takes something that I did get one question, very locally from within my apartment, from Olive, who's watching, which is it seems like this takes something that is sort of concurrent, like maybe rephrasing this incorrectly, but something like a ref, right? Which and sort of limits it in some way. And I think I'd agree, but it is sort of like depowering a ref in some way. But the trade-off is that. How would you describe that sort of that trade-off? Is that an accurate sort of observation?
Yeah, well, or I think maybe a way to think about it is it's making it more local, and so it loses a certain amount of power. It loses the ability to be used to communicate, but it also gains some simplicity of essentially when you're working with a FiberRef, you can almost think about you're working in a single threaded context or a single fiber context, because you are in a way, because any changes that anyone else makes is to their own copies and not to your copy. So you never really have to worry about concurrency in the same way when you're working with a FiberRef.
Yeah. Oh, and someone asked about the Discord channel. I will send another link. We try to post this in the chat. But yeah, just take a look at the Zoom chat. I will post a link to the Discord channel now. Awesome. Okay.
So I think the next step is probably to get to some code versus these like very poor quality diagrams that I do. So let's start off just playing with maybe an example like this and actually see the ref versus the FiberRef in code. So why don't maybe we'll start with a ref example. So my ref example, I'm just going to make a ref, and maybe we'll actually, we'll try to follow this. So we'll make this called Zymposium. And then we'll create fiber1, which is supposed to, so it's going to do ref.set kit. And then we'll kind of simulate this logging as just like, we'll get the ref, and then we'll flat map that. And so that will give us, we'll just call this our context, and we'll just zo.debug this thing. And then we will dot set Symposium, and maybe I'll just call this, and I'll just be an effect, and then Adam's going to be similar. And then I can just fork these two and run them. And I think maybe to make that even simpler for myself, I can just do kit zipper Adam here, which is going to fork both those things and then wait for both of them to be completed.
You can also, instead of this, maybe just do, if you just do .debug, it almost does the same thing.
Oh yeah, that's very lovely. Yeah,
and then we can give it a sort of like from kit, from Adam label. Perfect. So we'll see where we're looking at from.
Perfect. Okay, so let's try running this. And so our expectation is that this should be non-deterministic. Of we basically, if we're lucky, we'll kind of get this, but we won't necessarily get this. And let's try running, and we'll see if this turns out to be a good illustrative example. Oh, so there we go. So we ran it the first time, and we did not get the results we wanted, right? That because we were sharing this one ref, we ended up getting kit both times, even though we really wanted to get kit from one and Adam from the other. Mm-hmm. So let's try doing the same thing with a FiberRef. Yeah, and you'll see one of the things that's nice with it, there's some, we'll get into a little more specialized operators that we can use with FiberRefs that are really nice, but we can get and set them just the same way, and we call make to make them the same way. So there's a lot of consistency there, which is nice. And so let's make sure this is our FiberRef example. And now,
yay,
we're always getting the right result. So we saw here this idea that we could set and reset some context. And I mean, in this example, it's almost like trivial. It's like, I mean, why did we even bother like setting kit when we were literally immediately after that going to just like get it and print it out? But we could imagine maybe this is like setting some logging context, and this is some like giant HTTP requests doing all sorts of like data transformations and all sorts of stuff. It doesn't matter how complicated this thing is, it's always going to be working with this ref value that we set here. And that's also where the fact that these refs inherit their values when their fork comes in, because you can see here that like internally within zippar, we were actually forking two fibers. And so these are different fibers than the original one that this was forked on. But we got a copy of that parent value. And that also really helps us out of if this was a much more complex effect and it was forking a bunch of things internally, because all those things that it forked got a copy from its parent, they would all get this kit context as well, unless they set a different context internally. So we can reason about our code in this like local way.
One interesting modification might be to, for each of these, just call ref dot, so I don't know, autocomplete the Zymosphere.
Zymosphere.
That's crazy. Let's stick with that.
When we take over the world, we'll all be in the Zymosphere.
But let's, if we were to do this again, can we run maybe each of these with that here? Let me do, I'll just do ref example.
Yeah, right. You can run.
And then zip it into this one with the zio.debug, debug. So let's run both of them one after the other.
Yep.
Let's see what happens. So yeah, so we get the same, well, we have that broken issue there, but we get Zymposium in both cases. Now, if I were to delete all of these ref sets, this might be interesting, where we set it back to Zymposium at the end. Let's see what happens. Oh, that's interesting. Why did I'm actually surprised that the first one Did we run that again? Did I save that?
Yeah, let's make sure we save this because I don't. Yeah, that seems. Hold on.
I would think that the first one.
Yeah,
There we go. Okay.
yeah. So
oh,
we're going to see a couple interesting things here. So for this first one, we've just basically got kind of a race condition of like what we're going to get is just the last one, and the last one's going to win here. So like in this case, I guess we set Adam the last time, and so that's what we get. Here, we're seeing another interesting aspect of the FiberRef that we actually haven't talked about yet. So we said that when we fork a fiber, it gets an initial value equal to its parent's value. There's actually another rule here that when we join a fiber, by default, we get the value of the fiber we joined. Now we can see here that this isn't like particularly useful here of like, we probably don't want the like Kit or Adam to be the context here. We want it to be back to Zymposium. So what we really like to, one of the really nice operators on FiberRef is, and we'll come back to the joining and kind of to different ways you could even customize that more. But typically, like I would say the most common way that you would avoid this is if we go back to, not that. Okay, so this gets us our expected result of we like restore the original context because we set it back. But we can see here, there's like a little bit of a risk of like, one, if we got like interrupted here, we might not set it back, and we might do this and we might forget to do this, or do this and forget to do this. And so almost every time I'm actually using a FiberRef, I don't use this like set, but I use this operator called locally. And so what I would do is I would say ref.locally. And I'm just going to use a question here initially. And so locally takes two arguments. And the first one is the new value we want to set. So like in this case, it's Kit. And then the second argument is a ZO effect that we want to run with the FiberRef set to that value. So like here, I could change this to this ref.get.debug Kit. And then I'm going to do the same thing with Adam here. And now I'll run this. And so now we'll see that value always gets set back to that original value. And this locally takes care of that for us. And it works similarly like the way a zmanage does, that if this thing inside fails or gets interrupted, no matter what happens to it, it's going to set the value back to whatever the original value was before this when it's done. And so this here is getting close to, like, I'd say a really common pattern that you see to implement much more complex things, where you make some FiberRef that reflects some context you want to use. And then whenever you want to modify it locally, you just use this locally operator. And because this always takes care of setting back the original value, it gives you these like very like simple semantics of, whenever you're inside locally, you get your value, and otherwise you're going to get the value from higher up. And it ends up being really useful for a lot of things. And it avoids any problem of like, oh, accidentally kind of leaving that value too long, because you scope your changes to this particular scope. Does that make sense?
I get it.
So folks on Discord, any questions there? Should we hit on?
There was a question, what's the point of set Zymposium at the end of each effect? But I think now we've probably covered that. But
yep.
No, otherwise, yeah. Sorry, I didn't mean to force that on us. I actually forgot about the default behavior of it joins and overrides. I thought it was going to go off the local, but yeah, it's not local by default. Yeah, I usually use ref locally as well. So.
So we'll go into some like a more concrete example where we work through this, but maybe before I do that, I just to like motivate this, let me go over like some of the different things in Zio at this point that are implemented in terms of FiberRef, just so you can get an idea of like how useful these can be. So in Zio core now, log annotations are implemented as a FiberRef. Log levels are also implemented as a FiberRef. Managed resource finalizers are actually implemented as a FiberRef. Within Zio test, settings for whether to print the console from the test console are implemented as a FiberRef. The number of property-based tests is a FiberRef. The size of generated values is a FiberRef. And actually a bunch more. And so as you think about like, where could I use FiberRefs? Yeah, that's a great one, yeah. So there are, in Zio2, there are a bunch of parallelism operators of like, if you just do for each par and you have 100,000 things, in Zio1, that would like actually fork 100,000 fibers, which was probably not what you want to do, because even though fibers are very lightweight, like probably having 100,000 of them when you only have 8 cores is not really helping you. And so now there's actually a default parallelism that if you don't specify a specific parallelism with using that like for each par n, it'll use that default parallelism. And that's something else that is a FiberRef. And so all of these things have the property that there is some context or state that we're interested in. And we want to be able to modify that context or state locally. That's basically all we need to say that a FiberRef is probably a pretty good tool that we can potentially use for our problems. And this ends up describing a lot of things, because just like Zio ends up being powerful because the environment, like the things we do, end up having dependencies. So the environment ends up being very useful. A lot of the things we do depend on some context. When we're logging, we need to know what are the current annotations, what's the current scope or span we're in, what logging level are we in. If we have finalizers, we need to know what are the current open resources that we need to make sure we close if we blow up for some reason. If we're running Zio tests and we're running a test, we need to know what's our current settings for, are we supposed to print this out to the console or not? How big a thing are we supposed to generate? So this idea of having like some information that you want to be able to use to decide what to do ends up being pretty common. And so I think we end up finding a lot of use cases for these FiberRefs. And I think one of the reasons we were excited about doing this symposium is I think for that usefulness, there's a little bit of just, it's a different beast of you kind of need to understand the difference between these two, and you just need to spend a little bit of time on it to even understand like what this thing is and how it could be useful to you. All right. So why don't we try to do a little bit more of a fleshed out example?
Well, we did get one question.
Yeah, please.
What are the different methods of joining the FiberRef? Seems like the final value of the FiberRef will change depending on which one completes last. So yeah, what are sort of our other options?
Yeah. So let's look at that. That's a great thing to do before we go on the example, just to kind of understand all the theory of it. So if we look at this make method here, the most simple way to use it is just the same way we did with the ref, where we just supply the starting value. But the make method actually allows us to supply these 2 additional arguments, and they're called fork and join. And so the first one says, what do I want to do when I fork a new value? And so the most simple thing, and I think in most cases, you're going to end up just using it exactly like we used it in this earlier example. But the first one lets you say, well, maybe when I fork, I don't want to just give them a copy. I want to maybe modify the copy somehow. So you see this fork function is a function from A to A. So it says, well, given the parent's value, here's how I'm going to calculate the value for the child. So here, like this would be basically a function from string to string. I think at least get this to compile here. And then the second function we can provide is this join. And so this actually takes two A's. And so there's, I guess it's a little bit like you kind of just need to read the documentation, but the first one is the parent. And the next one is the child. And I get to say, well, do I want to use the parent's value? Do I want to use the child's value? Do I want to combine them in some way? So again, the most common thing ends up being we don't really worry about these so much and we do this locally. I would say that's almost every use actually in like Zio at least. But if we want to, we could imagine doing some additional things here. So like maybe we create another example here. So maybe we'll call this like fiber count example. Maybe we'll call it like forked fibers example. And so we could say, well, let me make a FiberRef. It's going to start with a value of 1, because obviously if I'm running, there's at least my fiber that I'm running on. And then when I fork, I'm not sure how well this example is going to work, but let's just play with this.
Would you want to add 1 when you fork?
Oh, well, I think here we can actually, in this case, I think we can just ignore it and we can just set it equal to 1.
I see.
Oops, sorry.
Oh, well, then there's the locally business. I guess we don't really want to do that.
Yeah, in this case, I think for this example, we could just do like these could just be Zio.units. Oh, we need to. Oh, we need to change the one we're running. And I think there's actually one more that's getting forked internally here. I'm not sure why that's giving us 4 instead of 3.
Would that be the implementation of zip-par doing something like that?
That may be the case. So like this is probably not the best example here. Another thing you could imagine is like, let's say that you had this being like a map of annotations and you wanted some way to combine them. So like imagine this was like a map of string to string, and it starts out as an empty map. We won't even override the fork, but when we join, instead of overriding, we could do a little map union thing here, which I guess I'll just do.
We don't just want to use plus plus? Is it going to be more specialized than just
Well, I think plus plus will work here, but we ideally we wouldn't want to like override values. But yeah, that's actually probably a great way to just at least for this get us going. And so here, then we could say this one could be like ref dot set kit cool, and then yeah, sure. What the heck we'll say. We'll do ref dot set Adam out, and now let's see what we get here.
Would it not be updated or something like this? Update.
Well, here we actually, I mean, it'll be fine to do update as well. The map starts out as empty. So I think either one of those will work for us here.
You guys screwed up something. So ref set, sorry, Adam.
No worries. Yeah, we got something.
Because we're calling set, doesn't it expect just a new value?
Oh, yeah, this can be just a map. Yeah.
I see.
Yeah, sorry. Yep.
A singleton map there. Okay, gotcha.
Yep, nice. Okay, yeah, let's try. Yeah. So yeah, we can see here that if we've got a nice way to combine these things, which a lot of times we do, because we can combine, if we go back to the prelude talks, we could call it an associative combining operation, or if we wanted to just be normal, we could just call it a way of combining. But if we have a way of combining these things, then we don't have to overwrite, so we can preserve information here. So this is also can be really nice if we've got something a little fancier where we want to be able to do that.
And I think just to talk about like the default implementations of these are, I think basically you get back what you put in, and then the child wins. So
yeah, exactly.
In our previous example, if we simply made it such that the parent won, I guess we
that
would
have solved that problem as well for us.
Yeah.
Mm-hmm.
So, yeah.
Yep.
Cool.
Nice.
Sweet.
Okay.
We'll want to do a more complex. Oh wait, maybe a couple questions. Sorry.
Oh yeah, please.
Is the child value enjoying the result of f passed in fork? I think the child value would be the value of the FiberRef of the fiber that you're joining back in, whereas the parents would be what you're joining into, if that makes sense. Fork
right.
and join.
So in like this example, if you join, the parent would still be Zymposium because the parent hadn't been changed, and the child would either be Kit or Adam, depending on which fiber was being joined.
Previously, now this locally will set it back. So
we'll set it back, correct? Exactly.
Fork and join parameters. When would you use these? Okay, I think maybe this is a little while ago, so maybe we did answer a little bit of that. Types don't allow you to do something with additional effects, right? Yeah. So you can't do anything effectual in here. These are for pure values like map. So, and I think one example is the one that you gave, which is this annotation map. And this is sort of what's used in Zeotest, right? For managing annotations.
Yeah.
Okay, and I can see you could use a FiberRef to accumulate the results from two tasks of A. Why not build the results into A? I think I might need some more clarification there.
I think maybe I can hit that. So I think the question is kind of like, in this case, we're like using this map to combine these things, but why wouldn't we just like return the map here and return the map here and change this to be like Kit zip-par with Adam, and then we just combine the maps down here? And the answer is basically FiberRefs end up being really useful when the information you're interested in keeping track of is different than the primary result of your computation. So like imagine that this thing was, imagine it was a test, and like the thing it's really supposed to return is a test result. It's supposed to say this test was successful, this test was a failure. But along the way, you're like also interested for like reporting purposes of keeping track of these annotations. So this gives you a way of keeping track of the annotations that, notice none of this is taking up the A parameter in like the Zio here. So the A parameter could still be the actual thing we're interested in. It could be the client response, or it could be whether the test passed or failed, or it could be the result of decrypting something. And then the FiberRef allows us to maintain some additional information of like how long this took, or how many times we had to retry it, or what context we were in. So that's really where the FiberRef and its way of combining is useful.
Yeah, I think going through the example will probably help, because there's definitely like a pattern to using this that can be very, very useful, and we'll probably give a better idea. But it does have these additional features as well that can be useful.
Yeah. Okay. So why don't we think about how we could implement a logging service?
Oh, sorry.
So the simplest method this is going to have is something called Logline. That's just going to log a line. But let's say we'd also like to have a method. Let's just start by playing with maybe these like annotations. So why don't we have a method called log annotate here. And so this will let us take, we'll call it a key. That'll be just, right now we'll just do strings to strings. If we want to get fancy and we have time, we can do things that aren't strings to strings. But right now we'll just do this. And then this is going to take some other ZIO effect. Okay, and Kit's been awesome in just setting up some of the like infrastructure for us here. And maybe just to like motivate this, let's do a simple example here. So we could, if we had this interface, we can hopefully do something. So obviously not the most exciting program here, but hopefully you can see, I think this is starting to do what we might want to with a simple logging framework. We don't have log levels yet, but we're able to log things. And we also have some concept of these log annotations that whenever we actually log something, we're going to log it along with the annotation. So when we log line howdy, we're going to know that it's coming from Kid and that he's cool. And so we're just doing, it's probably a nice example of using implementing services in ZIO2.
Is something, is it the right version? For some reason, service with ZIO is not in here.
Let me double check. We may have an issue, or we may need to reload. Right. Let's see. So we are on RC1, but let me try reloading. Close this again. It's also maybe, so it looks like everything's working except for one thing. So I think maybe some of this is, maybe I need to do the build on metals.
Oh, there we go. I think it's working now. I'll just stick it with that. Oh, maybe it's not.
Okay. I think, I don't know, metals may have just given up on us. Okay. All right. Looks like, yep. So then we need the, okay. So we've got our interface that has this log annotate and log line. We've got our accessors. So then we need to actually do this live implementation here. So yeah, let's comment that out. And this, let's say this is going to depend on the console service. So we put that as a parameter of the case class. Okay, so we've got the very simplest part of the log line, but now we've got a little bit of like a question for ourselves of what's the deal with these annotations of like somehow we're supposed to like log these annotations when we do the log line, but like where is that coming from? There's no annotations anywhere right now. And this presumably needs to update something, but like, what is that thing? And I mean, since we're doing the session on FiberRefs, you probably have a clue that FiberRef, but even if we just like thought about this, we go back to our idea of, do we have some kind of state or context that we're interested in? Yeah, we do. That's the annotations. Do we want to be able to modify it in some type of scoped way? Yes, we do, because when we annotate, like when we annotate down here, we want this annotation to apply to this thing. We don't want to annotate this thing. We don't want to annotate this thing. So we want to have some concept of scoping. So those are kind of our initial like criteria for a FiberRef would be helpful here. So I'm going to add one more dependency here. And maybe I'll call this annotations. And I'll make this a FiberRef of a map string to string. And now that's going to make it a lot easier. Now I have a way to actually do this. So Kit's implementing the logline method where we're just going to get the annotations and then basically just pretty print them. And the other method we have to implement is this log annotate. And so this log annotate, one clue we can have here is notice how this log annotate looks a little bit similar to that locally method that we looked at for FiberRef, right? Where we had some new or updated set of values and we had an effect that we wanted to run with those. So a lot of times the way we can implement these types of methods that kind of set the context is with that locally. So like here, I could do annotations dot locally. And this one, because I don't want to just set, but I want to update, I can actually do a little more. So I could say, maybe I'll say map in annotations dot get. Oops. And then I could say annotations dot locally map dot updated key value 0, and then I can just yield back my A. And I think we maybe have just one. Oh, we just have the little.
Oh, yes.
Okay. And so now I think this is going to do exactly what we wanted to. So, yep, we're doing the last step of our pattern of making the live layer. Awesome. All right, so let's try running it. Okay, so we're ready to run. Let's give it a shot. Oh yeah, right. Take that off. Yeah. All right.
Yeah, I think we don't need that necessarily, but we'll see.
Yeah, we don't need it.
Cool.
Okay, so and we see. I'm just going to copy this up here so it's a little bit bigger. but we got exactly our expected output. We got the logging for starting the program. Then we saw howdy, and it had the log annotations we wanted. And then we saw all done. And maybe let's try just playing with this a little bit more, just to kind of see some of the power. So yeah, so we're going to now have nested annotations. And maybe we'll let that one be there. And then, I don't know, maybe I'm more boring. I just say hello. So this time, what we hopefully want is, in this case with these log annotations, we want the ability to nest these annotations. So like we want the hello to be in the scope of both the kit annotation and the atom annotation. And then the howdy should be in the scope of the kit annotation, but not the atom annotation. So let's try running this. Ooh, you're doing fancy stuff.
Oh, let me hide that. Sorry, I was thinking of a recursively nested one that gets very silly. But
hold on, let's make sure we got our
logging example. Yeah, that's right.
Maybe we did say, hold on, let's see, or maybe we screwed something up in our.
Oh yeah, because there needs to be these need to be zipped together,
oh, that's a classic mistake.
Classic,
very nice.
Classic.
Very classic.
Cool.
Okay, so there we go. So we start our program with none. We get the hello from me with both annotations, and then we get the howdy with just the kit annotation, and then we have no annotations for the last one. And so this basically gives us this like very intuitive way of having these logging scopes. And we can say it worked exactly the way we wanted, of nothing ever got like carried over. And the implementation was pretty darn simple here. Right, this FiberRef was doing a lot of work for us in handling all these different, making these different copies and handing them around and setting them and resetting them. And all we really had to do was we could just get it when we wanted to get the value. And then we could do locally when we wanted to set the value. And maybe if we needed to, we wanted to do the get and then the locally. And another thing to notice here is, like here, this is an example of where the fact that we don't have to deal with concurrency pays off for us. Because if we were working with a normal ref, this pattern here of getting and then setting wouldn't be safe, because we might have someone else change the value underneath us. So we would need to do one of these more complex like update or get and set operators. But with the FiberRef, we know we're the only ones working with it. So it's totally fine for us to get the value and then to set it on the next line here.
And even if you did do an atomic operation, like if you did a whole bunch of, ZO collect all par, right? Those would all be happening in parallel, and people would still be, the context would be switched randomly.
Right, that wouldn't fully, right, that wouldn't solve the problem of overall. It would just make this one line. Okay, yeah, exactly.
Though I do think there could be an update locally method or something that takes an A to A there instead of a new.
I think we added it, at least on one version. Yeah.
Maybe some RC1, I see. Gotcha.
So yeah, that's in a way that took an embarrassingly short amount of time, because it's actually pretty straightforward to do that. But let's just maybe check in and see if anyone has any questions on this.
Could you run it one more time?
Yeah. Did you do your fancy stuff?
I made a pointlessly recursive example. Hopefully it makes sense. There we go. Yeah. So there we go. Lovely. Seems like it's doing something. Cool.
Yep. And the fact that the log annotation, or the FiberRef in general, is polymorphic in this A type also helps, because it lets you model different types of problems. Like here, we wanted to use this map of annotations. And the map implies to some extent that the order doesn't matter, right? That we have these annotations, and I think in this particular map, they happen to be in this order, but like here, the D4 is before the D9, and that doesn't matter because they're just like a bunch of annotations. But we could also imagine something where we have more of a stack, where maybe this is like only the most current one, and we could use like a list instead of a map. Though actually then the FiberRef in that case kind of takes care of itself because it will set and unset the most recent value. But if there are more complex data types, we can put whatever type in here we want, and we can modify either the way we're updating it, or if necessary, we can update those forks and joins to support more complex patterns. But most of the time, just having some, whatever the value is we want, and just updating the value locally gets us just about everything we need for something like this.
Yeah, and it's a nice thing to sort of wrap up neatly in a layer too, just to have that sort of hidden context inside of your service and not have to worry about threading anything around. It's kind of just like an implementation detail inside of the service. Very nice. It's a good pattern. Like use refs or FiberRefs inside of these service implementations when you need some kind of state that you want to abstract over.
Yeah, and it's also really nice if you have some type of configuration information. If you have like parallelism, and like you could have some initial FiberRef that sets it to whatever 8, and if for a particular scope you want to say, well, the parallelism should be 4, it should be 10, you can do that here. Maybe let me show 1 or 2 more things. So this is a really common pattern where we have essentially a FiberRef in the environment, right? Where the environment has the service, and the service inside of it has some annotations. I would say this is what I would recommend in most cases. If for some reason you really want this type of scoping, but you don't want to use the environment, you can actually use unsafe run to create a FiberRef outside of a ZIO effect and just have it at the top level of your program, and then just be able to work with that. That's actually something we do in ZIOs sometimes internally. So like if you, let me maybe show a simpler example. So
this at home, this is dangerous.
So like in ZIO, I can do this ZIO.parallelism. And so this says, in this case, none. I haven't set a parallelism. So there's no user specified parallelism. But now, let me try doing something like ZIO with parallelism 8. Now the parallelism is set to 8. And if we add the type parameter here, we notice there's no service in the environment here. And so what we essentially did internally is we did something like current parallelism, FiberRef int is equal to, well, I guess this was option of it. So let's do that. And so there we use this, so we just have a FiberRef outside of a ZIO effect, and then you don't need it to be in the environment. You can just work with it directly. So if you really, for some reason, you don't want to have it in the environment, this is a little trick you can use sometimes. Though if you can, I'd recommend staying a little more by the book and doing more like the pattern we have in this logging example here.
I think a lot of these also have just a sort of a syntactic thing. You can also chain them onto effects, right? I mean, same concept. The nice thing about functional effects, you can You're just
Mhm.
modifying values, so you'll have both variants there. And we could make a variant that did that for our log annotate as well. That could be nice, in fact, at times to add some extension method for Zio that basically wrapped it for you, but allowed you to instead just chain it onto any Zio effect. So instead of doing this, we could say log annotate like that. That could be pleasing sometimes when writing these locally esque methods. But I'll go back
Right.
to the wrapping way.
And so that's actually a great reminder of one other thing that plays really nicely with these annotations, which is aspects. So I think to even build on that more, we might want to have something like, maybe we call it annotated, that takes a key and a value, but no, that's not quite right. And so this is going to be a Zio aspect. So a Zio aspect is another one of the features that comes with Zio 2.0, and it basically takes test aspects to the rest of Zio. Test aspects are one of the things people really liked about Zio test, and were really nice for separating out the how tests get executed from the actual test you wanted to write. And Zio aspects let you do the same thing for your Zio effects. So you could say at some level, most of the time, at least when this isn't a silly logging example that just logs a bunch of things, what you really care about most time is like your actual like logic of like you're calling some database or some HTTP service, but maybe you want to add logging onto that. And so we can use these annotations to do that. And so we would define a new Zio aspect. And typically the nice thing about these is we can just delegate the work we already did. So here, this will just be that same Zio.log annotate. But now to exactly Kit's point, let's find, now I could do annotated Zymposium. And let's see, are we set up to run this, or should we start? No, we're running silly parallelism example. So let's do logging example. Yeah, nice.
Not quite.
Oh, this side, we just should get rid of this.
Oh, yeah. That's a lie. Cool.
Okay. And so now we've added this Zymposium scope to the whole thing, right? And so these aspects are also a really nice way to change the type or to modify the FiberRef, because we said one of the nice things about the FiberRef is whatever values in the FiberRef doesn't really show up in the type signature of the Zio effect, other than maybe adding a service to the environment. So like if we have log annotate here, right, we had this A and it's still an A. We're not doing anything with the A, and the A can be anything it wants to be. All we're doing is adding this logging thing to the environment. And so that's a perfect fit for these aspects, because aspects don't change the output or error type. They just potentially add new environmental requirements or failure modes. And so a lot of times these ways of modifying a FiberRef can be wrapped up in an aspect. So like in Zio test, there are a lot of things that let you say, well, make the random numbers deterministic versus non-deterministic, or log the console output or don't log the console output, or run with more samples for property-based tests. And all of those are those aspects, and it makes it really easy to like separate out this modifying the context from the rest of your business logic.
Cool. We did get a couple of questions.
Yeah, let's do it.
So yes, I think got some more stuff coming in, but I'll start from the earliest one, which was, yes, why, do you happen to know why it's the default join implementation takes the child rather than the parent?
Typically because the child has some additional information that the parent doesn't have. So like, if you think about a typical situation, you have the parent and the parent forks a bunch of children and the children do something else. And typically the parent won't really do anything else after it's forked the children. The parent kind of waits for the children to complete their work. And so the children are the one who have additional updates to what that value is that you might want to pull back in. And I think the other thing there is that if you didn't want that value from the child, then you would just do locally. So the presumption is if you haven't done locally, if you've just set and you've never reset, then like that's actually some potentially interesting information that you want to bring back in.
Yeah, in these examples, in this particular sort of the logging context, you tend to want to use locally, and that it does seem like it is the more primary way of operating with this, but there are other ways of using the FiberRef that don't necessarily throw away the child context as flagrantly.
Yeah.
Cool. And all right. Ooh, maybe I missed it. Does Zio aspect use FiberRef internally? I think the answer is no, but let you get that.
Yeah, sure. So Zio aspect itself doesn't, but a lot of Zio aspect implementations will. So all Zio aspect really is, and I guess this week, maybe sometime we'll have a separate Zymposium about this, but right now we'll just have this one. Let's see.
Beautiful.
Oh, I made a new Zio aspect. I'll call this Zio aspect very originally. Oh, and I think I have these wrong. Okay, there we go. So maybe let me see if I can format this. Okay. So this is all that Zio aspect is. So a Zio aspect is just a function from a Zio to a Zio that works for any environment, error, and value types as long as they're within these bounds. So Zio aspect itself doesn't need a FiberRef. It doesn't need anything because it's just this like definition. But the question would be, well, how could you define an implementation for this? Because the implementation has to be pretty general of, okay, it can know that these are within certain bounds, but otherwise these can be any values. And so there are operators that don't use FiberRefs, but one common way of implementing this signature can be to use a FiberRef, where we saw like here that log annotate and that locally method on FiberRef were things that took a REA and gave you back an REA. So they fit really nicely into this definition of a Zio aspect, but they're not strictly necessary for it or used in the implementation of it.
Cool. So yeah, I think that answers that one. And then, yeah, Phil Allen asked the question, which is sort of about, well, we've implied that there's maybe some secret things going on behind the scenes with FiberRef. You know, when you join, we recommend that it's doing things that are not the main purposes of the task, which is convenient. But how does it fit with the pure functional approach? It's a little opaque to keep these results out of the task type. By contrast, the error channel is part of the type. So yes, does that make sense?
Yeah.
I mean, it's kind of in the same way that a ref is not, when you modify a ref or have a ref, you're kind of doing things. And this one happens to be a little more hooked into the fiber mechanics, but it's kind of a useful, it is a side effect that you're modeling in a, I don't know. You answer it better.
Yeah, it's an interesting trade-off of what you want to model explicitly versus not explicitly, because you're right. You could imagine a world where you had like a fourth type parameter for Zio that was like the annotations or something. I think you end up not necessarily getting a lot out of that, because first, to the extent you actually care about preserving that type information, you really get that as part of the environment type. So like here, when we did logging and logline, that added logging to the environment. So the type signature very specifically is telling you there that that is using the logging service and maintaining whatever state internally the logging service needs to maintain. And I think beyond that, and for I think almost all cases, you'd probably say the fact that the logging service maintains some annotations of the log levels, that's a feature of the logging service. That's not something that is separate from the logging service. That's kind of its job to take care of that. So I think you do still get some of that represented in the type signature through the environment type. The other issue is that there can be a trade-off, I think, between explicitness and refactorability. So here we've done a pretty simple version of logging where these are all string logs, but you could imagine you have more structured annotations where maybe you have a annotation for the correlation ID and it's typed as a correlation ID, and you have an annotation for the log span and it's typed as a log span. Well, if you put all of those into the type signature, then it means if you have a big application and you want to add a new type of logging, or you say, well, now I want to keep track of spans, I wasn't keeping track of spans before, then everything you do, every type signature now needs like a new span parameter, or it needs to be changed to include the span. And that can be an obstacle to refactorability. So for example, with Zio metrics, one of the very conscious decisions we made there is actually to not even use the environment type for that, because we wanted to make it as easy as possible for you to add metrics to any service you want and not run into a problem of, you know, I've got 100,000 lines of code and now I want to add like a metric down here, and now I need to change all my type signatures to use metrics. So I think those are some of the reasons that there's actually, there can be value sometimes in not having something in the type signature. Like if you think about Zio test, it has type parameters for the environment test, how it can fail, whether the test result, whether it's successful or not, but it doesn't have some type parameter for all the different types of annotations you could have, which gives you the flexibility to add all sorts of different types of annotations that you want. And there are other ways that you can preserve type safety there. So like here, we just use string logs, but we didn't have to do that. Like if you look at Zio logging with Zio 1.0, they actually have logging of arbitrary type values, and you give it a function that it uses to combine them, and it actually does that for you. So I tend to think that we're better off not having this more explicitly in the type signature.
Yeah, I think particular domains like logging and like metrics and maybe analytics and other things are just kind of so ubiquitous in an application and almost orthogonal to the other business logic that it sort of is a bit of a special case. And maybe just for convenience and usability, but that's something we try to think about. It's kind of painful to have all of these tertiary tier of sort of orthogonal services that are for logging and metrics and plumbing and DevOpsy things, clogging up your type signatures. So, but yeah, it's certainly a trade-off. But cool. I think that was all the questions.
All right.
Well, yeah, that was fun.
Yeah.
Any final words on FiberRefs?
Try using them yourself. I think they can be one of the things that's more intimidating because it's equivalent outside of the functional world. That thread local is itself pretty esoteric, I think, where I think a lot of people, even who are experienced developers, might not have used it. And so with both not having the analogy and it maybe being less prominent in educational materials about Zio relative to like the promise and the ref, I think there can be a little bit of a barrier to using it. But hopefully you've seen from this that the FiberRef can actually be very simple to use, in a way more simple than like a promise or a ref, because it doesn't have the same concurrency concerns and can really help you solve any problem that requires some type of scope context, which is a pretty general description in a very elegant way.
Yeah. Great. Well, if anyone has any other sort of areas, maybe more neglected quadrants of the Zio ecosystem or feature set that you'd like us to cover, I think there are probably other data types and structures like FiberRef that could use some investigation. Oh, and someone asked about the code. The code, I believe, is this in the, can you share this, Adam, somewhere? I think it's probably in there.
I will post this up. Yeah, this is in the Zymposium repo. I think we got a little bit of backlog we got to do this week's, and we got to post last week's, and we probably have to move last week's because last week's was in the nominally FiberRefs file. But yeah, we'll get that up there for everyone.
Yeah, and we'll post a link, but you can also look for the Zymposium repository. But we'll post a link in the Discord. Yeah, people want more on aspects. Yeah, that would probably be good to talk a little more about, to explore that.
Yeah, we could definitely do a session on that. Yeah, I think so. Yeah, I think Z environment would be one, aspects another, and yeah, if people have things, we can just keep adding them to the list, and we'll just knock them out in January.
Yeah, and we'll be back again next Friday, 2 p.m. Eastern time. We'll try to be consistent at that time, and I think our meetup is correct. We'll try to stay on top of these things. But yeah, if anyone has any other questions, just reach out in the Discord or to Adam or myself. And yeah, something we've wanted to do for a while is also, I think we've mentioned this a little bit in the past, but since there are 30 people here, it would be great if anyone sort of wants any pairing assistance or has a project, something they're trying to convert to Zio or use Zio in sort of an open source context, or maybe even a professional context, and you get permission to sort of go over an example version of the thing that you're trying to pitch to your company or something like this. We'll get some free consulting that we get to sort of use as educational material. So that would be a fun thing. If anyone's interested in that, please reach out to us. We're pretty open. Any crazy ideas you have. There are many Fridays in 2022. All right.
All right. Well, bye, everyone. Thank you so much for joining us.
Take care.